Hi, this video is just an overview of the revisions that I came up with for our final project. This particular unit is for an honors physics class. It deals with electric circuits, and specifically the two different ways that you can hook them up, either in a series connection or a parallel connection. Just in looking at this unit, I just thought it was a little bit sloppy, and it was not very visually appealing, and it really didn't do a very good job of building a conceptual understanding for the students. It relied a lot on the mathematical basis, and that was really it. So I wanted to use a lot of the visual concepts from our class to try to help and make this a little bit more effective. The first thing I can show is the original worksheet that came with this unit, and I solved it, and I just kind of ran through it pretty quickly, but if you can look at it and see, not very visually appealing in any way. You've got two little pictures down here which are just circuit diagrams, and they don't do a whole lot. Within there's really not much space for the students to show work. You can kind of see that the work for problem 1 blends into problem 2, and it doesn't help a lot. Also, the directions for this take up about 7 lines just off the start, and so it really only allowed me to put 2 problems on this worksheet, whereas we'd like to have them look at a few more situations as well. So as opposed to this, what I came up with, first the blank one, this is the rewritten version of that same sheet. And just from class, looking at some of the visual components, I thought that the shape was a big part of this. If you look at the circuit pictures, they're all perfect rectangles. The data tables are all rectangles, and you saw those two things from the previous worksheet as well. What's new is I've put in some text boxes that match the shapes of those first 2 things. That give the students a clear area to put their work. It matches visually with the rest of the worksheet, and I think it just makes it a lot nicer for them to solve. Also, because I was able to simplify the directions at the top, you now see a third problem being added in there, which I think helps in our understanding. This next one is just the solved version of that same worksheet, and kind of the same idea. It's very clear the difference between those 3 problems. Nothing's blending into each other. Maybe they could be a little bigger, especially down here. I ran out of room a little bit, but I tend to write a little bigger than I think the students would, so I don't think that's a big deal. The other part that I wanted to have in looking back to this, and I know there's not a lot of, I'm sure, physics minds out there. Maybe you forgot some stuff you learned before, but definitely a math-based part to this class. There's also a conceptual side. These numbers are correct, and the students would know that, hey, I was supposed to get these as my answers, but do they actually know why those numbers are the answers? What is the reason for that? And this worksheet does absolutely nothing with testing whether or not they understand why these answers are the way they are. So a second addition to this worksheet is a second page here, which compares the circuit diagrams to water flowing around pipes, and I gave them some definitions up here for current, voltage, and resistance, how those terms compare for both circuits and for water, and it just asks them to, down here, can you use the pictures and your answers from the front page to make some conclusions for this unit for series and parallel connections. And this is something we can all come back and discuss. In a video that I posted on a YouTube site that the students can look at, I just blew up those pictures. I put them in colors. I gave them a chance to listen to me talk through how a circuit would operate with electrons flowing around, and how the water analogy works as well with the water flowing around. And I tried to use some color schemes that we talked about in our coursework, specifically, well, I guess color is one, just in a sense that the green arrows are going to represent areas that things would naturally move, charges from negative to positive around the wires, water from an area that's of high potential or high above the ground to somewhere down at the bottom, and so those would match up. The red arrows indicate places where things unnaturally travel. Water won't naturally go back up to the top, and charges don't naturally, since they're negative, go toward the negative plate because they're being repelled. So the green and red I thought matched up with a kind of like a traffic light, in a sense that they know when stop and go, and could apply it here. Also, within here. I tried to make the charges blue down here because that's what's actually moving, and here the water's blue as well as it should be, but just showing that the charge motion is equal and proportional to the water motion in the other one. And so what the students are going to do is just use these two as comparison tools, again with this sheet, and give us something to talk about more about why their answers are the way they are and not just what they are. So that's it, just an overview of my idea for this project. Hope you enjoyed it. Thanks for listening.